So, hello, my name is Thomas Nordlander. I'm the research director at IFE. It's a research foundation that has been in Norway for 70 years. And in our facilities in Halden, we have been running one of the world's largest and longest running research project. It's called HRP. It has started 1958 and have a budget of 10 billion Norwegian crowns. It's funded by 20 nations and 100 organizations in these nations. And the reason why you have not heard about it, it's because it's a classified research project. And it's only the last year that we have been able to lighten up a little bit of the secrecy. And that allows me to stand here today and talk about what we have done for the last 20, 30 years that today is a really hot topic in the Norwegian industry, like Internet of Things, sensors, artificial intelligence, neural network, virtual and augmented reality, and digital twins. So let me give you one digital twin that we created this summer. This is not just a virtual copy of the real machine that is filled with sensors. You can actually go in and do changes in this machine and see the effect of those changes will have, just as if you did it on the real machine. When we move down to this here, it's a pump. And it gets inputs from sensors when it comes to voltage, sound, and vibration. And we use AI algorithm to estimate the predicted remaining lifetime for this pump. That means that we can order and change it before it actually breaks down. On the screen here, you see a lot of information from sensors when it comes to pressure, flow, temperature, air moisture, sound, vibration, current, etc. This is not a digital twin from the nuclear industry, where we come from, neither from oil and gas. It's a Vega Polaris 2. It's a complete digital twin of this machine. I bought this machine a year ago to improve the coffee situation in our facility in Halden. And at the same time, I had a problem. How can we explain for the Norwegian industry what we have been doing for decades when we have applied it on extremely complex nuclear units? And then I thought, the espresso machine, you have a lot of the properties that you have in the Norwegian process industry. You have flow, you have high pressure, you have high temperature, you have pumps, you have circuit boards, and you use it regularly and maintain it. So what I did is I talked to some of the departments head we had, 8 different in Halden, and I created an internal project. It's called Dig Espresso Twin. And it allows us to show our capability, what we have done in the nuclear industry, but on a concept that is easy to understand. And the first department that got hold of the machine is IFE Sensor Lab. And they are the ones since 1950s have created sensors and put them inside the nuclear core of reactors in the world. And they filled this machine with sensors. And it's most likely the most sensor-equipped espresso machine in the world by far. I bought the machine used on Finn for 20,000 crowns, but we have put way more money into these sensors. I can give you an example. We have a lot of temperature sensors, and one sensor measures the temperature 1,000 times per second. And it's overkill for espresso machine, but not for a nuclear reactor. But just having the sensors is not enough. We need to make sure that the data goes from the sensors is prepared in for the algorithm. So we have created a full stack that will lift this data in real time for the algorithms. And then we have one department here. It's called Intelligent System. And they have worked with AI and neural network for 35 years. But we have not been able to speak about it because it has been in this project until recently. These are some of the facilities in nuclear power plant where we have installed and using neural network many years ago, but it's only now that we actually can say it. And we have more nuclear power plants around the world where we're not allowed to say. There's also quite a lot in oil and gas that we're not allowed to say either. But this department, they want to showcase some things, two things. Remaining useful life estimate of the pump in the espresso machine. So that means that they get the inputs when it comes to sound and vibration and the current used of the pump. And then that is the input for the AI algorithm to calculate the estimated useful life. And they want to do predictive maintenance in the pipe. And what they do is they look at the volume in the pipe and how that differs. And they measure that by looking at the flow and the temperature on different points in all the pipe. And that gives them an estimate how the volume have decreased depending on sediment, like calc in the water. And that allows us to find out where the calc is in the pipe system and how much it is. Another department, Anna said VR and AR, so I had to bring in this slide. We have worked with a department for 23 years with virtual and augmented reality for the nuclear industry. And this department have 12 researchers, and that is equivalent to 270 years of research in augmented and virtual reality. We own the engine here. We own the math engine here. The pictures you see in the middle is from Chernobyl, where we train people to remove cores during when the power plant is running. We do it for training and we do it for design. And this department used this espresso machine for two things. One, to put augmented reality on top of the machine to show what you can do with HoloLens, etc., to get additional information. But it's not super cool, but it's okay. But what it actually does, when they create this digital twin, they did a virtual representation of the espresso machine. And we had to take the espresso machine down into single parts and bolts. And they represent it. So you can actually see bolts, and you can actually virtually remove bolts, and some of the things would fall down when you do it. But it allows us to do a powerful interface for a digital twin. And when it comes to digital twin, it's a new word. Well, fairly new, but the concept is old. And you can stretch it back to NASA and some of the missions there. Our first digital twin in Norway, in Halden, was 1983, where we made a digital twin of a nuclear power plant's control room, where we can stream live data from nuclear power plants around the world into the control room, and you can do changes in this control room and see the effects of it, not in the real nuclear, but you can create a HAD smelter in the virtual one by doing this here. And currently this week, we're using this every year. So this week we have an American nuclear team that I'm not allowed to mention the name, but they are practicing blackouts for cyber attacks. So that means that part of the control room is down. Can they still manage to control the core? In the middle picture, it's a little bit mild, but it's actually one of the coolest pictures. This is from a work that we've done with a Swedish nuclear power plant that we also cannot mention. It's an area where they needed to have training. But at the same time, it's safety critical, so they couldn't allow people to train in the area. They have to be trained, but they have nowhere to train, and it's a unique area in the nuclear power plant. So what we did is we created a virtual environment for them to train maintenance in this area. But you can see it's holding a tablet, and this is 2010. To make it even more interesting, we added augmented reality in the tablet in the virtual environment. So it means that they can trade, they can hold up the tablet and get additional information, which cable actually is running current or not. And then when they trained enough, then they walk into the real one, and they wouldn't do any big mistakes there. The last one is complex. It's a loop in a reactor that we were working for France for. And I need to be a nuclear physicist to explain it, and you need to be a nuclear physicist to understand it. So I leave it at that and go over to our espresso machine instead. Because that is easy to understand. You have hot water, you have grinded coffee, and you get good espresso out of it. And most people of you buy outside here or get an espresso outside here. It's easy to understand. But the thing here is, it's not just a mirror of the real espresso machine with the data, but it allows you to fast forward alternative futures. So I can put in another pump than the original was in here, and then I fast forward 6 years and see how this pump physically affects the rest of the system. And with this digital twin, we also had researchers this summer flying over from South Korea, from KAIST, which is the MIT of for Asia. And they wanted to work with this instead of a new digital twin, a part of a reactor outside Seoul. They could choose, and they choose to come to us instead. So, what have we talked about today? We talked about Internet of Things, the sensors, the department that puts sensors in nuclear power plants in the core from 1950s. We talked about we had a full stack to prepare this data into the algorithm. We talked about AI algorithms for estimated useful life. We talked about virtual and augmented reality to visualize these things. And we talked about digital twin and how we can use that to draw insights and conclusions and training. And as a research institute in Norway, we are very keen on working with the Norwegian industry. We have some things to show. There are a lot of opportunities to get funded by Norwegian Research Council and EU to do research for you in the Norwegian industry. So if you're interested in this, and this is core to your business model, then let us help innovate you, and you can come down to us, and I promise you I will give you a really good espresso. Thank you very much.